Hello and welcome to another video made by Mr. Tai Fan from IB and A-Level Learning Center. In this video, I'm going to explain and help you understand the rule, the properties of a quadratic sequence. For example, we're given a form, the general form, or we can call this one the explicit formula for the quadratic sequence. A times n squared plus bn plus c. So we have three terms. This is the first term with the square of n, the second term with n to the power 1, and the third term which is a constant c. For example, we can take an example like this: 2n squared minus 3n plus 1. This is an example, okay? So the value n here in this sequence are the integer consecutively, like 1, 2, and 3. And step by step, we plug the value n here to be 1, 2, and 3. In the first case, when n is 1, we have a times 1 squared plus b times 1 and plus c. So it is equal to a plus b plus c. Similarly, when plugging the value 2 into this expression, the quadratic sequence, general explicit formula, we have a times 2 squared plus b times 2 plus c, and it equal to 4a plus 2b plus c. Similarly, when n is 3, we have 9a plus 3b plus c. So here the first three terms, and when we take the second term and minus, subtract the first term, which means taking this one, 4a plus 2b plus c, and subtract a plus b plus c, we have this following: 4a minus 1a is 3a, 2b minus b is b, and c cancel each other out. Okay, so we have this one, which is the first difference, 3a plus b. Similarly, taking the third term, this one, and subtract the second term, we have 9a minus 4a is 5a, and 3b minus 2b is b. So this is the second term, and therefore doing the calculation, the subtraction again, meaning taking this one, 5a plus b, and subtract 3a plus b, we have the second difference. The second difference is 5a minus 2a, 3a, which is 2a, and b minus b cancel each other out. So 2a is the second difference, and therefore after finding the second difference, like 2a here, we divide 2 and we get the value a. The value a is the first coefficient or the first parameter of this quadratic sequence. Okay. For example, here with example here, I would calculate the first three values when n is 1, 2, and 3. Here are n 1, 2, and 3. With n is 1. 2 times 1 squared is 2, minus 3 is minus 1 plus 1 is 0. So this is the first term, 0. Okay. Similarly, when n is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 6 is 2, 2 plus 1 is 3. And similarly, when n is 3, 3 squared is 9, 2 times 9 is 18, and then minus 3 times 3, 18 minus 9 is 9, and then plus 1, we have 10, the next value here. So here are the three values, the three terms, 0, 3, 1, 3, 10. The differences among them is 3. This is the first difference, okay, and that is 3 and 7 here. The second difference is here, 7 minus 3, which is 4, and then take that value 4 and divide 2, because that value 4 is equal to 2a, and therefore when we divide 2, we get the value 2, which is the first coefficient here, the coefficient in front of the second order n squared. Okay, so that is the first step. Similarly, to find other coefficient b and c, we move on to the next step. Here we have another example, which is a sequence, a quadratic sequence with the terms 4, 5, 8, 13, and 20. Here the first 5 terms, 4, 5, 8, 13, 20. The first differences are 1, 3, 5, 7. And the second differences are 2, 2, and 2. So they are constant. And the value 2 here is constant. It's supposed to be that constant. It must be the constant. And when taking this value 2, we divide 2, we get the first parameter a, which is 1. Meaning that we will have the first order 1 n squared here. Now we need to find the constant b, the coefficient b with the term n and the constant c. Okay. So to find b and c, we have the first difference. The first difference is 1, 3, 5, and 7. 1, 3, 5, and 7. To find b, we need to find a rule for that thing. 1, 3, 5, 7. 3a plus b equal 1. Okay. We need to go back to here. 3a plus b is the first difference between the second term and the first term. Okay. 3a plus b. So we have to memorize this thing. And the second difference is 5a plus b. So it follows the rule as 1, 3, 5. The odd values, odd integer, 3 and 5. Okay. Try memorizing that. Okay. Meaning the first difference, 1 here, is 3a plus b. And the second difference, 3, is 5a plus b. And similarly, the third difference here, 5, is actually 7a plus b. But we don't care about that, okay? The third term. We just need the first 2 terms here. So we have 3a plus b is the first difference, 1. And we already know we have determined a to be 1. And therefore, solving this equation with a is 1, we get b equal minus 2. Okay? And similarly, plugging b back into here. So we have 3a, a is 1, and b is minus 2. Now we need to find c. The simplest way to find c is to go back to the sequence, the series. Meaning now we have a to be 1 and b now we have solved that to be minus 2. So to get the first value for here when n is 1, 1 times 1 square plus, this is minus 2, minus 2 times 1 plus c equal to 4. And therefore we can solve for c. 1 times 1 square here is 1, minus 2 here, so that is 1 minus 2, which is minus 1. Minus 1 plus c equal to 4, and therefore c equal to 5. c is 5, okay? c is 5. Here. So the solution, the first term equal to 4, okay, the first term. Okay, so the conclusion is our sequence, the quadratic sequence is this one, n squared minus 2n plus 5. Okay, so that is the theory about a geometric sequence. Now let's move on to another example to see how we can find the parameters a, b, c in different cases. For example, I like to do an example down here, how to find the n term. Okay, there's a lot of theory over there, but I want to do some workout here. The first 5 term, find the n term given. Okay, now let's try solving this problem. Finding the n term of the sequence by calculating the second difference. We have this sequence 0, 13, 34, 63, and 100. Okay, let's start with writing the value n. The value n 1, 2, 3, 4, and 5. Now let's rewrite the sequence again. The first value is 0, second value is 13, 34, 63, 100. This is the sequence. Okay, the sequence. Now we find the first difference. From 0 to 13, the difference is 13. 13 to 34, difference is 21. 34 to 63, 13 minus 4 is 9, and then 5 minus 3 is 2, right? Check that again. 63 minus 34, yeah, 29. And 63 to 100, I think that is 37. Okay, here's differences. And try to memorize that this first difference is 3a plus b. The second difference here is 5a plus b. Now, moving on, finding the second difference. 13 and 21. 21 minus 13 is 8, right? Check that, sorry. 21 minus 13, yeah, is 8. And between 29 and 24 is also 8. And 29 to 37, of course, 8. And therefore, the constant a is this value 8 divided by 2, meaning a is 4. So now we have the value 4 for the term, okay, for the n square, meaning we will eliminate these two options, of course. A is 4. Now we're going to find A and B. Remember that 3a plus b is 13. And we have found that A is 4. So replacing it to be 4 here. 3 times 4 is 12, and therefore B here must be 1. Okay. And lastly, to find C, we go back to the first term. The first term is A plus B plus C equal to the value 0 in the sequence. Okay. Because when n is 1, with A plus B plus C is the first term. Remember that one also. So A here is 4, B is 1, and C must be minus 5, so that the sum is 0. And therefore C is minus 5, and the answer is this one. Okay. Thank you very much for watching. I will put the link of this website and example and exercises on this website in the description of the video, and I hope that we will spend your time practicing very carefully with this topic. I think this is interesting, right? Thank you, and I hope to see you later.